Maybe. Yes. Okay. All right, we're back, and we are going to talk about our question 3 here. And well, scoring guidelines are as follows. Let's see. Part A. What do we have to do to get approximation for R prime of 45? Somebody want to share? Pardon me? I'm not sure what you call fundamental theorem of calculus. That's not the right title. But you might have done the right thing.
It's like f of b minus f of a over b minus a.
That is, f of b minus f of a over b minus a is the right thing. That is a difference quotient or the formula for slope.
Okay.
It's the right-hand side of the mean value theorem. So you did the right thing.
Okay.
Fundamental theorem of calculus is when you do a definite integral and then you sub in your f of b minus f of a.
Okay.
Yeah, sub in upper minus lower. That's fundamental theorem of calculus. All right, that will get it right. That was a two-parter. So 2 points there. The answer should have been 1.5 gallons per minute, or gallons per minute squared. Okay, we would earn. All right, we're gonna earn. That's a nice brighter, maybe for the camera. Yeah. You'll earn 1 point for using the difference quotient and numbers from the table and interval that contains 45. That's between 40 and 50, so yeah. All right, so if you just did this, it's not going to be enough. You have to go ahead and put the actual values of R50 and R40 in there. And you can leave your answer right here without simplifying it to be 1.5. Yes, ma'am.
What if for whatever reason you did like, instead of 40 and 50, you did like 30 and 70? Would they still count off for that? Because that
Yes,
still,
that'd be okay.
But still contains 45.
Yeah.
But it wouldn't be 1.5.
It would not be, you'd lose the answer.
Correct.
But
Yeah, but it says a difference quotient using numbers from the table and an interval that contains 45. So yes, you could go, instead of 40 to 50, you could go 30 to 70. You could go, heck, 30 all the way to 90. You could go 0 to 90.
I was just curious.
It wouldn't be as good of an approximation as what we're doing from 40 to 50. Yeah, but I mean, it says on an interval that contains 45. So in this, they've been specific enough in this scoring guidelines that yes, I think your scenario would score okay. I would prefer we do
I did
the
40
tightest
50,
interval
I
around
was
it.
just curious.
I guess this is a question that comes in from part C. But are we good on calculator active questions to leave it like in a fraction, say 3 over 2, or when we get down to our Riemann sum, to leave it 20 times 30 plus x plus x plus x?
You can still leave it in a big old expression, unsimplified, even on a calculator active question. As I spoke in class today on like the one that I kind of messed up, here's a trapezoidal sum. I forgot the 1/10 coefficient out front. So when I did take the time to punch in my trapezoidal sum, and I got an average temperature of the T to be 529 degrees Celsius, when it was never hotter than 50 degrees Celsius, I knew, wait a second, I screwed something up, and that let me go find it and fix it. So, as I said both classes today, you don't have to simplify it, but maybe you do it off to the side just to kind of check the reasonableness of your answer and catch little errors like that. But even when I was doing my Riemann sum here on my calculator, I was wanting to type in 55 at one point, and I just hit the 5 one time. I happened to look on my screen to catch that, but that would be a place where, oops, I screwed up by actually calculating it. Okay, part B. The rate of fuel consumption increases fastest at t equals 45 minutes. What's the value of r double prime of 45? Well, there we go. It's going to be 0. That one's definitely a concept question. The fact that you got the second derivative of 45 to be 0, you earned a point. Bank it. If you got a correct reason, now, anybody need me to kind of explain why? Okay, that's fine. As you read this, it says, let me get the bigger copy of the prompt up here. There you go. And Tyler, here's an example of where I liked having the picture there. You mentioned a moment ago, would it help if I had the picture? Yeah, I could draw my left Riemann sum in there. Helpful. All right, the rate of fuel consumption is increasing. Okay, think about the wording. R is the rate of fuel consumption, and it's increasing. Ooh, that's inferring the derivative of R. Fastest. That's talking about the maximum of the derivative of R. I'm going to have a maximum of the derivative of R at t equals 45. And if anything has got a maximum, we know it's either got a peak that's a horizontal tangent line derivative of 0, or it's a sharp point maximum. One of those two things is happening. So if the rate of fuel consumption is increasing, thus R prime is increasing fastest, then R prime has a peak. And either R prime is going to have a horizontal tangent, thus its derivative, which is R double prime, its derivative will be 0, or its derivative will be undefined. I know it's not undefined because they told me it's a twice differentiable function. So I know the second derivative exists for all times t. So I went a little bit more than they did in my explanation there. And I did discount the fact that it couldn't be undefined. I scratched that out pretty quick, so penmanship's not the greatest. But I said since R is increasing faster as t equals 45, then R prime of t has a maximum at 45. Thus the derivative of R prime is 0. And I'd stated already that that's R double prime. I said R double prime cannot be undefined since R is twice differentiable. So it's a matter of the words, I think, interpreting what they're saying here. Rate of fuel consumption, R, is increasing. R prime, fastest, maximum. Approximate the value of 0 to 90 of R of t dt using your left Riemann sum. Okay, and is the approximation less than the value or greater than? Explain your reasoning. That's probably why they gave us the picture. They already told us that a strictly increasing function. That's important. That's going to tell me, oh, there's not a time where, which is impossible here. Well, no, not really. There's a way, the plane could be using at a faster rate at one point and slower rate at another point. That could be true. But anyway, they told us it's always increasing, which is going to be necessary to know if this is an over or under approximation. Because if it changes, increasing and decreasing, we're always using the left, well, some of them will be under and some of them will be over. So, what did you think on that one? What was the left Riemann sum? Anybody tally it up? 3,700. Yep. And I said, so there's my Riemann sum, approximately 3,700 gallons, and this approximation is less than the value of the integral since R is increasing, and this is a left Riemann sum. All the justification we need.
I feel like I over-justify sometimes.
You know,
Which isn't bad. Like this one, I was like, approximation is less than because RT is strictly increasing, so the left endpoint will always create an inscribed rectangle.
that's fantastic. That reader's going to say, man, this girl knows her stuff. You know, you're not going to, I don't think, hurt yourself by overanalyzing, as long as you don't say something false, of course. But that guy was, part C was a 2-pointer. So if you got the value of the Riemann sum, and Lee, back to your question a moment ago, could you have simply left it as 30 times 20 plus 10 times 30 plus 10 times 40? Yeah. Did you have to punch it in as 3,700? No. But, yeah.
I just wondered if there was a difference between calculator active and inactive
No.
questions.
There's not. Once again, that's arithmetic. You know, the calculus people don't really care that I can punch in 30 times 20 plus 10 times 70. You know, that's not important. All right, and part D. Explain the meaning of the integral from 0 to b of R of t. What did you think about that one, Mr. Tala? No, sir. Now, for one thing, you're not using the second fundamental theorem of calculus. You said because of the second fundamental theorem. The second fundamental theorem of calculus is when you take the derivative of an integral defined function. The second fundamental theorem of calculus is, let's say r of x is defined to be the integral from 0 to x of the square root of sine of t dt, or something like that. If you're asked to find the rate of change of r, then the derivative of r is going to be simply just subbing that dude in times the derivative of him. That right there is the second fundamental theorem of calculus. What you're thinking of, and you started out right, is the fundamental theorem of calculus. The integral from 0 to b of r of t dt is going to calculate some other function. I'll call it, I don't know, a of t, just for lack of anything to call it. Evaluated from 0 to b. And so that's going to be some a of b minus a of 0. And what I heard you say was just a of b. I didn't hear you say minus a of 0. Now, very often when we sub 0 into a function, yeah, it turns into just 0, but not always. And I have no idea what the r function is here. It's polynomial, yeah, it's going to be 0. But if it's logarithmic or trigonometric or exponential, it won't be 0. It'll have a value. Now, but think about this now. What are the units for r in this problem? Gallons per minute. This guy taught. Think about when you're trying to interpret this. Think about the units. For me, that's all-encompassing powerful. This is gallons per minute times what's dt measured in? Minutes. Yeah, that's my change in time. That's minutes. And what would gallons per minute times minutes give me? Gallons. Yeah. So this is going to be the total adding up of, or the total accumulation of gallons from time t equals 0 to time t equals b. Right there. That's it. That's the answer. And you didn't even have to specifically state a theorem used. Because if you state the wrong one, you're going to be in trouble. All right? So indeed, this guy is going to calculate the total number of gallons used from time t equals 0 to time t equals b. Now, I know, think about it in a distance problem. Motion along the x-axis. If this was the rate, which would be the velocity, what would the integral of velocity calculate for me? Yeah, okay, position, true, okay. But now, over an interval, say 0 to 10, what would the integral of velocity from t equals 0 to t equals 10 calculate for me? Displacement. Displacement. And that doesn't take into account, that doesn't add up the distance right plus the distance left plus the distance right plus the distance left. It's just the difference between where you started and where you ended. Why don't I have to worry about the distance right and the distance left and the distance right and the distance left in this scenario?
Because it's constantly increasing.
Because it's constantly increasing, yeah. My derivative is always positive in this guy. Because the rate of fuel consumption, all those data points were positive values.
So then if it wasn't constantly increasing, would it have needed to be like the absolute value of V of t to answer that question?
No, the question was, for the video folks here, is if it wasn't always increasing, would it have to be the absolute value of r of t here? It all depends on what they're asking me to interpret it. So I would just basically say, if I was doing an increasing, decreasing kind of curve for this guy, I would say it would be the difference in the gallons used at the end from the gallons used at the beginning. It's the total net difference. Because this guy is going to be gallons at the end minus gallons at the beginning. Okay. And then the second part. What's that make us think of right there? Yes, Georgia?
Really quick, like I said that the integral of RT provides for the total amount of fuel used. Do I need to specifically mention like gallons of fuel?
You said gallons of fuel used, didn't you?
I just said amount of fuel used.
Well, I believe because in the prompt, they told me fuel was in terms of gallons.
It
Need
says
to
indicate
mention-
use units of measure in both answers.
Did it?
Yes.
Oh,
Last sentence.
yeah, that would be a problem, Georgia.
Uh,
Where it does say indicate units of measure in both answers, we definitely want to put that.
Okay.
And again, this little analysis right here. RT is gallons per minute times minutes, this will be gallons. That's, I mean, if you think of it that way, it's almost a no-brainer, you know.
Yeah.
Good thing to do that. And now I would specify, state total gallons of fuel used from time t equals 0 to time t equals b. Put that in
I had
there.
that on
Or on the time interval from 0 to b, something of that nature. Okay, how about my second part? Ben H, you got this one? Oh, go ahead.
Is that the average?
Average of what?
Gallons of fuel.
Average rate of fuel consumption. This is indeed average value of a function. Well, average value of what function? The R function. And what was R? Rate of fuel consumption. So this is going to be the average rate of fuel consumption from time t equals 0 to time t equals b. In, measured in what? Units.
Gallons.
Gallons per minute. Yeah, because units had to be measured. So, in this part, that was a three-pointer. You get 1 point for the meaning of the definite integral, a second point for the meaning of the average value function. You lose a point if you don't reference time b, like time 0 to time b. If you don't mention that, you lose a point. Okay, so that's a kick, a big one to see. And then you get your third point by having the right units in both answers. If you put the units in the one part but not the other part, you're not going to earn that point. Because it does say both.
So I would still get the point for the meaning, I just wouldn't get the point for my units.
That sounds correct, yes. You get your meaning point but not your units point. And of course, we do want to reference, you said you referenced the 0 to b times 0 to b. Yeah. Good. Good. So, I don't have the scoring statistics on this 03. It'd be interesting to see what we scored. I might be able to pull it up, but
Google it.
Google it. I'll look and see. I should be able to get it real quick.
I imagine this one would be pretty high.
I would hope, but you never know. Let's see what we can find real quick. Let's see if this goes all the way back to 03 or not. I'm not sure that it will. Ooh, wait. Yeah, we got it.
It's
Okay.
just so bright now.
Scoring statistics in 03. Okay. Question what, 3?
Yeah.
The mean was a 2.42.
Wow. Sweet.
Yeah, mean was it, so how'd you guys score in comparison?
6.
6s?
Was
Yeah,
it out of
5?
9?
Out of 9. They're all out of 9.
Well, I think I might have missed a point.
All right. So 6, 8. You know, you guys do that, we're rocking.
Don't you feel so much more prepared now? Than you did like 5 seconds
It
ago?
made me feel
I
better.
just don't understand how it's possible
Megan,
that everyone scores.
It made me
that.
feel better for chemistry. It was like
It's beyond me.
You're well prepared. And that's the difference. And you're smart. All that good stuff.
All my educational.
All right. And again, you know, this review process is so key. I mean, when we started this, what, week and a half ago, 2 weeks ago?
Yeah.
You guys wouldn't score nearly that well on that question. Well, you might have. You did it last year. Maybe, guys.
No.
No.
I can't do this.
All right. Let's see, next in your packet, you've got, let's see. Okay, let's work through the O2, number 6. We'll give it a few minutes and work through this guy and see what we can come up with.
How you can get on?
Oh, I thought it was the very next page.
It is.
Is it the top?
Yeah, that one.
It's the top half.
We're gonna run
Those are
through
scoring guidelines.
that.
I Xeroxed it and didn't
Oh.
include the scoring guidelines.